So, there are a lot of parts to the lab. I think I'd like to just spend time going over the last few. Does anyone want me to go over the first few questions? Is there anything specific that anyone wants me to go over how to do? Because I think I saw a lot of you guys doing this stuff. I kind of want to just do the explosion one. Anyone has an issue with it? And if you guys have any questions on the other stuff, let me know and I'll be happy to go over it too. So the goal is we have this sprite sheet that exists here. Looks like this. And I want to go frame by frame and use this explosion to animate it. So this is a sprite sheet with an explosion. Each one of these explosion sprites is like 100 pixels wide by 100 pixels tall. And the goal was to make it look like it's animated, like so. Starting with so I'm going to do this in two parts. One, I'm just going to prove that I can go frame by frame, and then I'm going to control how fast it does it. Okay, so here's my SDVA203. As I mentioned in class, whenever you're dealing with images in SFML, there's two types of variables that you use. One is called a texture, and a texture basically represents the file on disk. It loads the file on disk and stores it, while a sprite uses a little bit or the whole texture and draws it to the screen. The sprite is basically the runtime representation. Shapes like this can also be used to represent it as a sprite. Shapes can have a texture applied to it, or you can explicitly just have a sprite type, which is something that can just draw a texture directly without a shape. Okay. So because there's two parts, usually the first thing you have to do is you have to load the texture. And SFML has this tutorial on the lab about how to load the texture. So at the very top of this lab, I had a couple links on how to load textures and use sprites. And the first thing they do is they call this function on the texture called load from file. And this requires a path to the file itself. And then in the example, they have this like if statement here, which basically has you handle the error in case the explosion texture can't be loaded. So what I'll do here is I'll return 1. And the reason I do this is that if I fail to load here, it's going to return an error code of 1. So if I change this text so it actually was able to load it, if I name it something bad like this and I run it, it will close immediately as opposed to running the game. Cool. So that means that there's an error loading the texture. You can also just have it print out something to the screen. If you want to. Like so. And that way, if you type in something weird, you'll see it in the little console window in the top left here. See how it says, make this bigger. Failed to load image, explosion, blah, 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 reason unable to open file. So SFML will actually tell you, we'll actually spit this out, but then we'll spit out our own little error afterwards. Couldn't load explosion texture. This is actually a good opportunity for me to show you guys. I'm going to just mention this and say that this is something you should be looking up to, because a lot of game companies will be looking for your knowledge of this. So you can use cout. We've been using cout for a long time. However, be aware that there's other ways to print stuff to the screen. There's something called a Printf. And Printf works a lot like cout. It works a little bit differently when it comes to printing out values, though. For instance here, it still prints out couldn't load explosion texture, like that error message. So printf can be used in that way. However, I want you guys to look up, if you actually just search for printf C++, you'll find what's called the printf formatting rules. So this basically includes how to print all these different things. It has this table. And what this table is used for is for printing numbers. So if I were to print out, let's say I have a variable here. Like that, called random number. And I want to do a cout of that random number is, I would have to do this and then print that out, SDL, ENDL, like so. If I want to print out the same exact string using printfs, all you do is random number is %d with a new line at the end of it. And then you pass in the random number as an argument to this function. These will give me the exact same lines. However, cout is a lot more verbose. It requires a lot more typing, even though I get the same exact output. The benefit to doing it this way is that I can actually use random number. I can actually have multiple formats. I can actually have multiple numbers. And this %d right here represents a decimal. It says print out a decimal value. I can use multiple arguments in this function, and it'll print out a number for each place in that string. So random %d gets replaced with the first argument here. The second %d gets replaced with the second argument to that function. If I wanted to print out it as a floating point number, I just should do %f, and it'll print this number as a floating point. So you can change how a value is interpreted. So it prints out 41 as a floating point, but it doesn't understand how to do that because it's an integer, so it prints out 0.000. So here, this table, if you Google it, will explain D, F, all the different format types, and explain how to use them inside your printf statement. Reason why I'm mentioning this is that you might see code in a lot of places using printf like this to print out strings. And the way that you usually look at it is you look for the %sign, you say, oh, %d. Then you go to the end and you look at the first argument that's passed in after the quotes, and you say, okay, that's the value you're passing in here. You go to the second argument and you say, oh, that's the value passed in here. And this is very common, at least for at Blizzard, like we use this everywhere. So printfs, we have our own version. Dev, printf, something like that. It's the same idea though. I just wanted to take a tangent there to talk about it because error messages and stuff you can use cout, but there's another way you can print them. Printf is basically kind of like the C way, the C style way, not the C++ way. It's a legacy way of doing it. The nice part about printf, you don't need to include IO streams. You don't actually need to include that at all. It just works. It's built in. And you can print to a console, or you can use that to also like print to a file. Okay. So we have our explosion texture, and it's going to be loaded. I'm going to create a sprite. And with sprites, you have to set the texture that you want to use on that sprite. And this thing, so whenever I open up my parentheses here, I get little pop-ups explaining a little bit more about how to use that function. So for instance, this function set texture takes two arguments. The first is a const sf texture reference texture. What does that mean? That first argument, it takes an sf : texture variable type, which we have up here, and it takes it as a reference. So that means it's going to pass in a variable, and it's going to let you pass it in and modify that variable. It's not actually going to copy that variable, it's just going to pass in the memory address of it. And const means that it is not going to change. The only thing that really matters here is that when you see something like this, it means that you can just pass in, it's not a pointer or anything like that, you just pass in the variable directly. And all that really means is that it doesn't spend, it's as cheap as possible. It doesn't actually copy any of this information around. It just tells you, hey, look at this location in memory, and that's where I want you to use that value from. So set texture here allows us to specify a texture, and this is really, really fast to do. And then all we're going to do is we're going to draw this explosion sprite. We're not going to do anything else other than change what we're drawing. Instead of the green circle, we're going to draw this explosion sprite at the end. So now we have our sprite. And so now we can see that we've drawn this entire sprite, all of the pieces of it. Now I want to make sure that I want to be able to draw a single piece out of this sprite. So that is where the second function, and this is all in the link here, in the second link. So there's two ways to do this. You can either specify, let's see, where is that? Right, so here, when you're loading a texture from file, you can either specify a rectangle here for where you want that texture to be drawn from and how big that rectangle is, or this is, so you can specify a texture rectangle here, and this texture rectangle is basically, imagine a box that's drawn around one of these. That's what you're specifying, is where do you want that box to be and how big do you want that box to be. You can make that box be like this if you want to, or this shaped. You can change the size of the shape of this box however big or small you want it to be. Typically you want that thing to match the size of one of these sprite sheets. Another way you can do this is on the sprite itself, right here, you can call set texture rect, and you can do the same thing. The first two arguments are the position of where you want that rectangle to start, and then the second, the third, and fourth argument are how big you want that rectangle to be. So here, I'm going to call set texture rectangle, and it takes an integer rectangle, and I'm going to choose to start at 0, 0, and it's going to be, let's say, 100, 100. So I want to draw this one right here. That's where I'm putting my box. Okay. And now you guys can see it's drawing the top left corner of it. Okay. What happens if I make this box like twice as big on both X and Y?
It's going to go diagonal down.
Yeah, it'll go diagonal down. I'll draw 4 of those, right? Because that's how big the box is. I made this box basically like this. Okay? And I can make it 300 by 300, which would make me draw 3 of these. Or I can make it long like this. I have my choice here. The width here can be 700, while the height remains 100. And it'll draw the entire first row. So it has that whole first row. Or at least 7 sprites of it. Okay. What if I want to draw, like, I don't know, this one right here, right? I have 0, 0 is the box up here. So 1, 2, 3, 4 rows over, and 1, 2, 3 rows down. What is the coordinate of where this box starts? If it's 4 rows, 4 columns over and 3 rows down. 400, because I know each one of these things is 400 wide, and 300, because I know each one of them is 100 tall, but I want to go 3 rows down. Now I'm going to draw that one, this texture. Right? That's where I put the rectangle. And I can choose to put this rectangle anywhere. These numbers control that. I'm going to do something, though, to make my life a little bit easier. I'm going to change this a little bit. I'm not going to actually change what I'm drawing. I'm just going to make some variables to make my life a little easier. I'm going to have a variable called size, and I make it 100. So I'm going to replace this with size here and here. And then I'm going to replace this with 4 times size, and this with 3 times size. So now I know I'm 4 columns over and 3 rows down. I'm going to pull the 100 out of the equation and have it used separately. So there, I still get the same image. The reason why I do this is now I can use size here, and what I'm also going to do is I'm going to pull these 2 numbers out too. I'm going to make what's called a column variable, make it equal to 4, and a row variable, make it equal to 3. I'm just going to take this and take column times size and row times size. I'm just replacing what I'm using for variables. But the nice part about this now, if I want to change the column that I'm drawing on, so if I run this, it's going to look exactly the same. If I want to change the column or row, I just bump this up. Maybe I bump that up a couple numbers, and I will get a different version of the sprite. So see there? I'm going to change the column to be 2. So column 2, row 5. Notice I'm just changing those numbers. I get column 2, 1, 2, 3, 4, 5. This one. So just by changing the numbers here, I can get different sprites. This is going to be important because we want to animate this thing. And the way we animate it is by changing these values here. Okay. I'm going to start the row off at 0 and the column off at 0 too. Okay. So it's going to draw the very first top left sprite. So how do I move the column? If I actually have this rectangle here, I want to move it this way. What am I adjusting here? I'm going to be adjusting the column, right? This is my column here. What if I just, inside my loop here, just took column and did plus plus here? I just added one to column. Watch what happens. It's going to be really fast. Oops. I'm adjusting my column. However, this right here, look, I'm only doing this one time, right? I need to do this all the time. I need to do this inside my loop here, okay? I'm moving this texture rectangle because if I don't do this inside the loop, even though I'm adjusting the column variable, it's not changing where this rectangle is. This rectangle, you need to tell it to update the rectangle deliberately. You're the one in control of that, which means that I have to put this thing here. It doesn't really matter if I put it before or after. I'm going to put it before I adjust the column, so I'm going to run it again now. Now I'm doing this inside my loop. Now my column is being updated all the time, and it had a blip there for a second. You guys saw it like blip white? Let's see it in the top left corner here, like so. But it's kind of going, one, it's stopping after. Why is it not looping that? Why does it go to the end here? It should be going back here, right? Because the rectangle is, there is no rectangle here. Well, if you pass in a position on the texture that is outside the bounds of it, it actually will just draw nothing there. It'll pull nothing from that texture. So what I have to do is I have to make sure that when I get to the end of this column, I pull this rectangle back to the beginning again. And how do I do that? How do I take this rectangle and move it back to the beginning? Does anyone know?
If statement.
I can do an if statement. What do I do an if statement on?
It passes if equals 7.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8.
Well, so that's 0, right? So
If column is equal to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Actually, if column is equal to 9, because this is 0, 1, 2, 3, 4, 5, 6, 7, 8. When it gets to 9, that's when I want to reset it over to 0 again, right? And I reset it. Okay. So now it's looping again. And I can change the row that it's running on. So I can change row to be 1, and it'll draw the next row instead. So it's looping over that. The timing is wrong, but we'll fix that next. So I'm going down the rows here, okay? So let's pick that row here. Let's pick row 2. How do I make it so that this thing is slower? How do I make it so it doesn't go so fast? Remember, frame rate is important. How do I slow down the animation here? There's a lot of different ways I can do this. I could slow down the frame rate, right? I can make my computer run slower. I could literally make this thing run slower. Like so. This will make my computer run slower, and thus it'll, because I'm printing out 100,000 things to the screen every frame. Watch, it's not even drawing it. That might be too slow. Let me make this more like 1,000. Can you guys see how it's actually slowing down? By me printing out stuff to the screen. This is actually an awful way to do this, by the way. This is not really the great way, but it works. I can control how fast it goes this way, though. Notice when I don't have the console up, it's still running really fast. And then when I'm doing this, it's running slower. If I minimize that, it runs fast. Then bring it back up, it runs slower. So that's the trick, though, is I need a way to slow down how often it animates. How about if I have a way to control when I add to this column variable? Okay. What if instead of adding 1 to this column variable every time through the loop, I only did it sometimes, right? How about I have my animation counter variable? I can just have it be 0. What if I just took this thing and I just did plus plus on a counter, and if the animation counter is greater than 1,000, I wrap this whole thing in a loop, like so. So what if I did it so that only if this animation counter went over 1,000 would I animate it, and then I would reset this thing back to 0. This is one way you can do this. I can literally just have a variable that just counts up to 1,000, or whatever number I want. I don't know, 527. It doesn't really matter what it is. But basically, what this value is going to count up to 527. Then this if statement is going to go true. It's going to immediately set this thing to 0 and then reset my animation. So you guys can see it's doing the same thing, but without my logs here. But at least it's animating the same. Looks like my counter is a little bit too high. Maybe I do 100 here. Okay. The problem with this is that exactly the same reason why when you're running an old Asteroids game on a new machine, how long it takes to count up to 100 is going to be different on every computer. Some computers are going to count to 100 really, really fast, which means they're going to see a much faster animation. Some computers are going to count to 100 really, really slowly, so they're going to see a slower animation. So how do I count for that here? It's going to be the same idea, however, I need to account for time. So by the way, if you guys did this for homework, this is totally fine, and this is a legitimate way to do this for the homework. But if you want to, this was an exercise on looking up information on SFML. If you want to use time, you can actually use time here instead of a number that you add up. You can actually just tell how much time has passed. Because what I really want is I want my explosion to animate at 60 frames per second. I want this thing to move this thing box 60 times a second to a new explosion sprite 60 times. And I want to control that number exactly. And the way I do that is with time. So there's two parts to it. I'm going to delete this animation counter temporarily. Same idea though, just to keep it a little bit more clear. SFML offers something called a clock, which is pretty simple. It's a clock variable type, and you put SF::clock just like you would with sprite, and this clock here is something that keeps track of time in your game. And you can call a function on it to tell you how much time has passed since the last time something has happened. So what we're going to do is this clock is kind of like a stopwatch. Every time that we're going to ask it to tell us how much time has passed since the last time we asked for, since the last frame has run. This clock here is going to give us back a delta time. Delta time here, remember from my example here, it basically represents how much time has passed since the last time a frame has happened. So I'm not going to assign this equal to 0.016. I'm actually going to ask the clock for the delta time. And that is by calling a function called restart. Restart basically says, hey, set your clock's internal timer back to 0, but tell me exactly how much time has passed. And give it to me back as seconds. Okay? So restart your clock, but tell me how much time has passed. That's what this thing returns. And give it to me as seconds. If you want to break this down a little bit more, there is something called time, which is a little bit confusing. There's something called time and SF::time. This represents a unit of measurement of time. While a clock is an object, imagine it like an actual wall clock. This thing represents a unit of measurement. It's like an integer or a float. It represents seconds or milliseconds or microseconds. And so you can use this instead. That's what restart calls. And then delta time ends up being time converted to seconds. So you can do this as well. Either way, we have this delta time now. Okay? I'm just going to print this out to the screen. I'm going to use my Printf here. Like so. This %f, I'm putting brackets in because that's how I like to format things, but you can do that too. dt is %f here, and fps is 1 divided by delta time. Okay. I'm going to do a printf to screen. I'm going to add a new line here. So you guys are going to see on the left the delta time on the console here. Oops. I'll also do this. Convert that to a number. My FPS is wrong. There's my float, there's my delta time divided by that, and let's just print this. My FPS is really high. My delta time is really small, so I'm getting, here. Can you guys see how fast my FPS is? I'm getting like 1600 FPS. But look at my delta times on the left. Look how small they are. 0.002, 0.0008. The cases where my FPS is like 1600, there's my FPS is 2000 at one point. My delta time is really, really small in that case. But so what I need to do is I need to add up all these little delta times together to tell me how much time has passed. So I'm going to add one more variable here, which is elapsed time. This is going to keep track of how much time has passed. And all I'm going to do is I'm going to add my delta time into my elapsed time here. And I'm going to print that out as well. Like so. Okay, so I'm printing out all three pieces of information. So delta time changes every frame. So does elapsed time. But elapsed time basically is counting up every frame. So can you guys see how my elapsed time is literally just counting up in seconds? Little, tiniest little bit every second. It's adding the little bit of delta time that's on the left into my clock, which is on the right. This basically represents how much time has passed. Now, I can use the value on the right, the elapsed time, to control my animation. Because now I can say, if my elapsed time is greater than, how many frames a second do I want? I want 1.016. If my elapsed time is greater than this is basically 0.0166 seconds, reset my elapsed time, and then advance my call. This will let me animate my explosion at 60 FPS. Or, if you wanted me to write a little bit different, like so. 1 divided by 60. So I can control how fast my animation is by adjusting that value 60. If I want to go a little slower, I just change this from 60 to, say, 24. And now my animation is slower. This elapsed time variable, remember, look at it, look at the value on the left now when I'm printing this out. It counts up all the way until it reaches 1 over 24, which 1 over 24 is 0.041. Every time it hits 0.041 or higher, it resets it. So see how it never gets higher than 0.044-ish? It never actually counts up past that because that's what's controlling my animation. Now the only thing left to do, now that I have my animation, this is animating at 24 FPS, is now what I want to do is I want to make it go down in rows. So every time I go to the end here, I'm going to reset this back, but I'm also going to bump it down 1. Okay? So I'm also going to do row plus plus here. It's going to animate one time and then stop, but you guys will see how it works. That's it. Let me start this on row 0 as well. Can make this thing go slower or faster. Maybe I do 36 FPS. If I want this thing to loop over and over again, the only thing I need to do is say if row is equal to, well, how many rows are there? 1, 2, 3, 4, 5, 6, 7, 8. Reset the row as well. And that'll make this thing loop indefinitely now. Any questions? All right. I'm going to put this up on Zool so you guys can grab it. And I'll give you guys a break now, too, so you guys can take a break. So I'll give you guys a break, and then come back by 10, please, and then we'll resume the lab. And if you guys have any questions on this, I'll be happy to answer them, too.